All right. I got all my stuff here. I just need to look at it real quick.
You have it on paper as opposed to online?
Yeah, but it's just some it's some tests, so.
Okay. I was going to say, if it's online, I can go to the website and pull it up on the joint screen here.
Mm-hmm. Okay, this might be hard to do.
To verbalize?
So, yeah, to verbalize, basically.
Refresh me again as to what kind of math we're doing. What do we?
Algebra 2.
Algebra 2? Okay.
Yeah.
Most Algebra 2 can be verbalized. Is it functions, or are you looking at a graph?
We got a variety of things here.
Well, you can take a picture of it and send it to my email address if you like.
Why don't we just start off with factoring?
Okay. Give me the function to be factored.
Okay. 2x squared plus 3x minus 35.
That's it?
Yeah.
So it's an expression, not an equation.
Mm-hmm.
But it can still be factored. Okay?
Okay.
Now, it's been a while since we've worked together, so I need to know that you know how to do a regular, easy factoring problem. Because if you don't, this is where we need to start.
Mm-hmm.
Now, the one on the right is easy because it's got a 1 in front of the x squared. Whenever there's a 1 in front of the x squared, that is a first level quadratic that can be factored very easily.
Okay.
Do you know how to factor that? Because they teach you all kinds of different methods in school. They teach the California method, the diamond method. I kind of have my own method. And
Okay.
my priority is making sure that people can do first level quadratics. Because if you take a test, you'll have 9 problems like this, and you might have 1 like that.
Mm-hmm.
So there's no point in us starting with the higher degree of difficulty if you can't do the lower degree of difficulty.
Right.
Because the process is very similar for doing both of them. But it changes about halfway through if you're doing a harder one.
Okay.
Let's work on the easy one first. Let me tell you how I do it. It's 3 steps. The first step is you separate the x squareds. Can you still hear me, Jameson?
Yeah.
Okay. In other words, this first term, what you're doing when you're factoring is the reverse of foiling. That's what you're doing. If you know how to FOIL, then that tells you an awful lot about how to factor the resultant quadratic. But this x squared term comes from x times x.
Okay. Yeah.
Now, the next most important thing to do is determine both signs. Not just one sign, both signs at the same time. What must both signs be over here on the right?
On the right, plus?
That's the one we're going to work on before we do the one on the left.
Okay.
Because the first 2 steps are exactly the same. In other words, we split up the x's and then we determine both signs.
Okay.
How is it that we can determine both signs? It's all based on this right here.
Okay.
The fact that that is a plus 10. There's only one way to create a plus number for that constant. And that's if both signs are the same. Remember, the last step of FOIL is to multiply those 2 numbers together. So whatever they were, they multiplied together to be a plus 10. So they have to be the same. They either have to both be minus or they have to both be plus. How do we tell whether they're both minus or both plus?
By what the first one is?
By what the middle one is. Middle term is minus.
Oh, okay, yeah.
That tells you they have to both be minus. As long as the constant has a plus in front of it, both signs have to be the same. They're either plus plus or minus minus. Just look to the middle term, it'll tell you what they are.
Okay.
Step 3, and this is where the simpler ones differ from the harder ones. On the simpler ones, step 3 is very simple. Factors of 10 that add, because of that plus sign, to the number 7. So what factors of 10 add to 7?
Let me see if I can set up like a table here.
And just think about the number 10. Think about two numbers that multiply to 10.
2 and 5.
Okay, and they add to 7. It doesn't matter whether I put the 2 on the left or the 5 on the left. I've got the same two factors. So that's how you do an easy one. Okay, I'm going to give you one more easy one. Just make sure you get the pattern down correctly. Now this is a slightly harder one than the first easy one we did. It's got 4 steps to it, but the first 3 are the same. First step
is to find the what the sign is, like whether it's x.
Write these down, because once you memorize them, the factoring is going to be a piece of cake for you. It's not that hard. It's just that everybody forgets the steps and then they try to do the whole thing in their head all at once. That's not the way to do it. So the first step is you separate the x's.
Okay.
What's the second step?
Look at the signs, minus, minus.
Both signs. What do they have to be in this case? There's only one way to produce a negative 12 constant. If the signs were the same, we'd have a positive number there.
Oh, okay.
So what must they be?
Plus and minus?
Correct. It doesn't matter whether I put the plus on the left or the minus on the left. I'm going to end up with the same thing. That also is different from doing these harder ones. Okay, the third step is still the same, except now we're looking at a minus sign in front of the 12. So what we need are factors of 12 that subtract to what?
To x?
Not to x, to the coefficient of x. Last time we needed them to add to the number 7. What do we need them to subtract to? We need them to subtract because of that negative sign. What's the number in front of x?
1.
Correct. What two factors of 12 subtract to 1?
Hold on.
Here, let me help you on your factoring. That's the first set of factors of 12. Now I can cut this one in half, which means I got to double this one. I can cut this one in half again, which means I got to double this one. That's it. That's all there are.
Right.
Which set of factors subtract to the number 1?
3 and 4.
Okay. Now, that's the same 3 steps as we took before. But before, it didn't matter where I put the 2 and where I put the 5. But now, because one of them is a plus and one of them is a minus, it does matter.
Oh, okay.
So the fourth step is to take the bigger of the factors, 4, and put it with the sign of the middle term. So where's the 4 go?
To the minus?
Which means the 3 has to go there. So these were both very elementary factoring problems This one was 3 steps. This one was 4 steps, because you need that 4th step to tell you where to put which number when you have a plus and a minus. Okay? All right. So that's first level factoring. Let's talk about this problem we have here.
Okay.
Because you can't really do these unless you know how to do the easy ones. First step is the same. What's the first step?
Separate the x's.
Go ahead. What 2 terms, when multiplied together, will give you 2x squared? Because that's the only place 2x squared comes from, is these very first 2 terms. So when I say split up the x's, I mean split up the 2x squared.
1x and 2x.
Perfect.
Okay.
Now I can check that real quickly. That multiplies together to be 2x squared. I know I've done it correctly. Second step. What is the second step? Tell me.
Find the signs.
Okay. What are they? Based on the fact that that is a negative 35.
It's going to be plus and minus.
Correct. Now, this time, plus minus is not the same as minus plus. Because 2x is going to be multiplying one of these numbers, and x is going to be multiplying the other. So, to allow for either situation, I do it like this. Okay? It's either going to be plus minus or minus plus. I know that. Now, the third step starts out the same, verbally. What is the first part of the third step?
To find the
Factors of...
The factors. The factors of 35.
Okay,
and
stop there.
3.
There's no more rule you can throw on it. In other words, they don't subtract to the number 3. They don't add to the number 3. We just know that they're factors of 35. So first of all, let's examine all of the factors of 35. What's the next factor I can come up with besides 35 and 1? Can't divide 35 by 2.
Yeah.
Can't divide 35 by 3. I can't divide it by 4. Can I divide it by 5?
Yes.
7. And what's the other part going to have to be?
5.
Okay. And that's it. I can't divide 7 by any of those numbers. So that's the only 2 factors. Now the whole process becomes a trial and error process.
Okay.
Okay. And by that I mean I just have to pick one of these sets of factors and start plugging it in and see if I can produce that middle term properly.
Okay.
I know I'm going to produce 2x squared, and I know I'm going to produce minus 35. So the only term that I'm not sure about is that middle term. Well, when you're doing a trial and error process like this, always start with the 2 factors that are closest together. That's just going to work 90% of the time. It is. It's just the nature of the problems that they give to high school students in Colorado is they give you the factors that are the closest together. So we're going to start with 7 and 5. And I'm just going to arbitrarily start with 7 there and 5 there.
Okay.
Okay? Now, what we have to determine is, does that produce this middle term? We know it produces the 2x squared, and we know it produces the minus 35. But does it produce a plus 3x? Well, that plus 3x comes from the inside and the outside of FOIL. There's the inside, there's the outside. What's the inside multiplied to?
7x.
Put the sign with it because the sign is critical here. What's the outside multiply to?
10x?
Nope.
No.
Minus 5 times 2x.
Oh, that goes with a minus. Okay. I wasn't sure.
Yeah, you need to include that sign.
Negative 10x?
Okay.
So
Add those
x
two
squared?
together,
No.
you get minus 3x. Well, that isn't the correct middle term, is it?
No.
It's the correct number.
Mm-hmm.
Get the correct number but the wrong sign, the only thing you have to do is move the 7 to the negative and move the 5 to the positive.
Oh, okay.
And so our answer is 2x minus 7 times x plus 5. Now, let's check that because it's always a good idea to check just your middle term. I mean, I've done this enough that I know if you get the right number and the wrong sign, you just move it. But you can see why. I'm going to now get a minus 7x in the middle, and I'm going to get a plus 10x on the outside. That does give me plus 3x. Therefore, that's the right answer.
Mm-hmm.
Okay? So, you'll notice that the first step was exactly the same. Second step was almost the same, except I had to put plus minus on both, inside both parentheses. And then the third step was just playing around with whatever factors you come up with for the number 35.
Okay.
Now, problems that are tough are problems that have like a 24. Because a 24 has about 8 factors.
Mm-hmm.
You know, it's 12 and 2, it's 6 and 4, it's 24 and 1, it's 8 and 3. The more factors you have for this constant, the harder these problems become because, I mean, we were lucky. We got it on our first try and our second calculation, which isn't bad. That's fairly optimal. But let's go back for a moment before I leave this problem, because I want to point out a very important thing. First of all, this is where we were at, right?
Mm-hmm.
Now let's say that I accidentally, instead of putting the 7 on the left, let's say I put the 5 on the left, and I put the 7 on the right.
Okay.
Okay? Now when we check what the middle term would be, we get plus 5x, get minus 14x, add those two together, you get minus 9x. Mm-hmm. So, if you do not get the right number, you've got these reversed. In other words, there's no point in moving the 5 down to the negative sign and moving the 7 down to the positive sign, because all that's going to give me is plus 9x. Mm-hmm. So it tells me a lot about what not to do. In other words, it is trial and error. I used no thought or logic into putting the 7 on the left and the 5 on the right to start out with. I was just guessing. Okay? Had I guessed wrong, my first trial would have produced the wrong number. Therefore, I know the 5 can't be on the left and the 7 can't be on the right. So I immediately know to go up and swap them. Remember, there's 4 possibilities. It can be 5, 7, 7, 5, minus 5, minus 7, minus 7 plus 5. So I know the 7 has to be on the left. Now, that'll produce the 3. It just produces a minus 3. So I immediately know it's got to be minus 7 and plus 5. In other words, by your first step, you learn a lot of information by your first trial.
Right.
Now, if it doesn't work with 7 on the left and 5 on the right, or vice versa, what do? You go up and you try 35 and 1. Mm-hmm. Same process. You just arbitrarily start and see if you can produce that middle term. It's all about producing that middle term. And you can see that this part of the process is an integral part in solving it.
Right.
Whereas with a first level quadratic, this is just a check. That's the only time you really use that. But with a harder quadratic, anything greater than 1 right there, this is part of the process for solving it. Right here.
Right.
All right. What else do you
got? Problems on expanding.
Okay.
I think that's FOIL, right?
Yep. Well, I don't know. Give me the problem and I'll see, because you can expand a lot of stuff. Logarithmic expressions. Usually when they talk about expanding, they're talking about logarithmic expressions.
Okay.
In other words, remember those log rule? We talked a little bit about logs, right? So the log of 6 is equal to the log of 2 plus the log of 3. That's called expanding it. In other words, I could replace that with a 6. But it's better to factor it, because then you can replace it with 2 log expressions. But go ahead and give me your problem. It may or may not be a log expression.
2x plus 3. And then parentheses around that squared.
Okay. So what this means is 2x plus 3 times 2x plus 3. So this is what has to be FOILed. So go ahead and FOIL that. F stands for the first. So 2x times 2x
is 4x squared.
O stands for the outside.
2x and 3.
Multiply. You're multiplying in all of this. Plus 6x. I stands for the inside.
Which would be 6.
Plus another 6x. And finally, the last stands for plus 3 times plus 3.
So plus 9.
Okay. Notice that that's the only place you get any x squareds, and this is the only place you get only numbers. The two middle terms always get combined. So there's your answer. Now, if they would have started you there, we would get back to the 2x plus 3 times 2x plus 3. In other words, if they told you to factor that. It's actually a reasonably difficult one to factor, just because. Let's start at the bottom. Okay, we got the answer for this, right?
Yeah.
But if I started with that and I said factor it, what would you do? What's the first step?
First.
What is the first step? Verbalize it.
Is
See, if you verbalize it, you're going to remember it better.
Yeah, 4x squared times 12x?
No, the first step in factoring is split up the x's. And by splitting up the x's, I really mean splitting up the x squared. I really should put it like that. That's what I want you to memorize. The first step is splitting up the x squareds. Notice you have two choices here. You could do 4x times x, or you could do 2x times 2x. We don't know at this point which one is the better choice.
Right.
So what rule do we use? The two closest factors, which are 2 and 2. Or 2 and 2 are closer than 4 and 1 are. Okay, and again, this is trial and error. Okay, Okay, there's not very many factors with 9. What's the second step?
Find the signs.
Okay, what are both signs?
Plus.
Because that's a plus 9 and the middle term is a plus. Okay? And finally, we got factors of 9. Well, there's 9 and 1 and there's 3 times 3. Which one are we going to try?
Say again?
There's 9 and 1. That's one set of factors of 9. And there's 3 times 3. Which one are we going to arbitrarily try? By arbitrarily, I mean, I don't know what the answer is yet. I'm not looking at this over here. Okay? I'm trying to factor it as if that was the only thing we were given was factoring this problem.
Okay.
So I'm going to start with 3 and 3. I'm always going to use the factors that are closest together. Now, let's check the middle term. If the middle term is right, we're done. Well, that gives us plus 6x. That gives us plus 6x. Bingo. It wasn't as hard as it could have been.
Yeah.
But whenever this number gets to be bigger, then you got multiple choices on how to even split up the x squareds. So these can get quite difficult. If I were to give you a problem like this, that might take you a half an hour to do. Really, because there's so many different possibilities on how to factor 12, and there's equally a larger number of possibilities on how to factor 24. So you'd be doing trial and error with maybe 8 different possibilities, all in an attempt to produce that term. So that's what factoring is all about. What else you got?
A couple, like 3 just simple solving problems.
Okay.
2 parentheses 3x minus 4 close parentheses equals 8x minus 4.
Okay. What's first step?
Do the parentheses.
Yeah, get rid of parentheses and denominators. That's always my first step.
Okay.
Or exponents, if there's an exponent. But usually it's parentheses and denominators. We don't have any denominators, so let's get rid of the parentheses. So what's the next line that I want to write?
2
No,
times.
tell me what the line is. I don't care about the math of it. Just tell me what line is going to come next.
Like what?
Well, you're multiplying, you're distributing the 2 is what you're doing. What do you get when you distribute the 2?
6x
Keep going.
minus 8.
Okay. Now, what's the next step going to be?
To get rid of,
gathering like terms. Remember that expression. You're gathering like terms. In other words, you're going to gather together all the x's and you're going to gather together all the numbers.
Okay.
Now, the next choice you have to make, you know you're going to gather together everything, but which side are you going to put the x's on and which side are you going to put the numbers on? Because you want to put one on one side and the other on the other. Which side is a good side to pick to put your x's?
Left side.
Let's keep the coefficient positive. Always. That's your number one rule for determining which side to put the x's on.
Okay.
If I put them on the left, I'm going to have a negative coefficient.
Yeah.
So I'm going to put them on the right, which is going to give me that. Which means I've got to put all my numbers on the left. So what goes on the left?
Plus 4.
No. When I moved that one over, I got rid of that, but I didn't get rid of that minus sign.
Oh, so minus 8 equals 2x minus 4?
Okay. If you want to go through that intermediate step, I do both steps at once. In other words, I gather all my x's and I gather all my numbers at the same time. Okay. So now gather all your numbers on the left.
With minus 4 on both sides?
Well, what you're doing is adding 4 to both sides.
Oh, yeah. Right.
In other words, you're always doing the opposite of whatever that was doing.
Yeah.
That was subtracting 4, so you got to add 4 to get rid of it.
Mm-hmm.
When I when I add 4 to minus 8, I get minus 4. So minus 4 now equals 2x. What's the last step?
Divide by 2.
Okay. So that's how you solve that. And that's a fairly common algebra problem, where you have x's on both sides of the equation, you have numbers on both sides of the equation. It's a linear equation. Notice that we only have x to the 1 power. We don't have any x squareds. We're not going to produce any x squareds. So it's not quadratic in nature. So this really is easy to solve in that you just gather all your like terms. Even if you have x squared, you gather all your like terms. It's just that x squared is not a like term of x. It's a different type term. So you have to separate them. In other words, I can't add these two things. There's no way to add those two. That's the final answer, x squared plus x. Okay, what else you got, Jameson?
Could you, if you, okay. I was going to ask you to keep that up there.
What, did you have a question about the last page?
I was going to ask you to keep it up there real quick, just so that I could write all of it down.
Sorry, unfortunately, I cannot retrieve that page.
No, it's okay.
I can write the problem from scratch and work you through. You want to take a picture of it?
Yeah, that was what I was going to do.
Correct?
Yeah.
Okay. Tell me the next line.
6x minus 8.
Equals 8x minus 4.
Yeah.
Now the next line. Do both steps at once. There's no reason not to do them at the same time. Usually I suggest always do math one step at a time. But when you repeat a problem over and over again, you realize I can do both of these steps at the same time. The only decision you really have to make is which side to put which thing on.
Right.
So we're going to put the x's on that side. That takes care of that and that.
And then negative 4 on the other side.
And then x equals negative 2. Go ahead and take a snapshot of that.
All right, there we go.
Okay. Incidentally, I do record all of these. And you don't really need to take a picture of them. Just need to go to that link where you can see the recording, and you don't have to watch the whole hour. You know, you can fast forward it to where we talked about factoring or foiling or whatever it is we're doing. That might be the easier way for you to review this stuff, but I don't know.
Okay.
Okay, what else you got, Jameson?
Negative 4x minus y equals negative 6.
Okay. Now, because we have two variables and only one equation, we can't solve for x and y. There are literally an infinite number of solutions for x and y, as there always are when you have more variables than you have equations. And we have two variables, one equation. What we can do is solve it for x in terms of y, or we can solve it for y in terms of x.
Mm-hmm.
Usually you solve these for y in terms of x. In other words, you want to have y all on one side all by itself, and you want everything else on the other.
Okay.
Which side's y going to be on?
Right side?
Correct, because we want it to have a positive coefficient. Okay. So I'm immediately going to put it over there. I don't go through this business of doing this because I don't think it's helpful. In other words, the left side always goes to nothing. And the right side, the way I do algebra is if I want to move that y to the other side, I just move it and change its sign. That's the way I think about it.
Mm-hmm.
So I got the y on the right, but there's still that -6 over there. And this is what I got over here. So how do I get that -6 to the left?
Add 6.
There's your solution right there. Or, if you like, I can solve it for x. To solve for x, I would have 4x equals y minus 6. Then I would divide both sides by -4. So I would get y minus 6 divided by -4. So that's another solution. But that's the best you can do, is to solve for one variable in terms of the other.
Okay.
Okay. Now, if you had a second equation to go with that first equation, then you can solve for everything. You want to take a picture of that or anything?
I got it down.
All right. In other words, I'm sure you've encountered simultaneous equations. And both of them will have an x and a y in it. And as long as you have two of them, you can solve for x and y. But you can't solve one equation.
I just didn't have the other one on the same page, so I forgot to.
Oh, so there was a second equation?
Yeah.
Okay, well, let's do it. What was the first equation again?
-4x minus y equals 6. I just wrote the other equation on the back side of the paper, so I forgot about it.
Okay. So
and then the other one is 2y equals 7x plus 5y. No, wait.
Yeah, no, that's fine.
Okay.
2y equals 7x plus 5y?
Yeah.
Okay. Now, we've got two equations and we got two variables. We should be able to solve this. What two methods have they taught you for solving simultaneous equations?
Substitution and elimination.
Perfect. When you use elimination is when both equations are in standard format. That is in standard format. I've got the x term first, I got the y term second, they're both on the left side of the equation, and I got the number on the right. In other words, standard format is this: ax plus by equals c. Okay? Mm-hmm. If they're both in that format, then elimination is the way to go. If one is not in standard format, then usually substitution is the way to go. Okay? Now, in order to substitute, I've got to solve one of these equations for one variable.
Right.
And then substitute it. So the easiest one to do is actually the top equation. Let's go ahead and solve it. Again, it was y equals minus 4x minus 6, right? In other words, to solve it for y, which I just did, I moved the y over to the right side and the 6 to the left side. Now I'm going to go to my second equation. We'll call this equation 1. We'll call this equation 2. And wherever I run into y, I'm going to substitute minus 4x minus 6. So starting here, minus 4x minus 6, always in parentheses, equals 7x plus 5 times what?
Negative 4x minus 6.
Okay. Now notice what we have. One equation, only one variable. We've eliminated the y. Everything is in x. This is a straight linear equation. We can solve. I'll go ahead and do it just to speed things up here. Get rid of the parentheses. Gather all like terms. Which side am I going to put the x's on?
On the right.
Well, we have got two of them over there already. Let's go ahead and turn that into minus 13x.
Okay.
Minus 30. Now which side are we going to put them on? Which side will make the coefficient positive? That's what you have to answer.
Right, the left side.
Okay. And it's 5x.
Mm-hmm.
Now, I just have to move this minus 12 to the other side. So it must be minus equals minus 42. Okay.
Mm-hmm.
Now, that means x is equal to minus 42 over 5. So we've solved for one variable, and now we can go back into either equation, substitute for x, put minus 42 over 5, and notice that we will be able to solve for y. Actually, I know already that y is equal to minus 4x minus 6. I just have to substitute minus 42/5 for x, and I'll have a number. And that'll be the answer for y. And that is always the way you do these problems, is you first solve for one variable, and you pick one of the two equations and substitute that solution for that variable, and you'll be able to solve for the other variable.
Mm-hmm.
You need that up there anymore, or can I erase it?
What was y equal to? After
Well, we didn't finish the solution because these numbers are so bizarre.
Oh, okay.
I think you probably made up this second equation.
Maybe.
Just because you couldn't find it and you came up with one that produced really hard fractions.
It's on the paper. I just don't know if it's the right one.
I'm not trying to call you a liar or anything.
No, yeah, I'm just not sure if
Could be
it's the right one.
It's just I didn't finish through with it because now we got y equals minus 4. X is minus 42 over 5 minus 6. Now, if you want to do that arithmetic, be my guest. That's what
right.
y is equal to.
Yeah. All right.
And they usually don't give you problems like that when they're trying to teach you this, because it just confuses someone when you have these fractions like this. Whereas if you make your solutions integer numbers, whole numbers, then people get it a little bit better. All right. And x was minus 42 over 5. So that's your two solutions. Yeah, no, they're perfectly capable of giving you a problem like that. Just the way things unfolded, I figured that probably wasn't what they did. But all right, what else you got? We got about 15 minutes, a little bit less.
Yeah. Maybe finding volume of a circle.
Okay, there is no volume of a circle. There's a volume of a sphere.
Yeah, that's what I mean.
There's the area of a circle. In other words, a circle is two-dimensional. I actually heard a very interesting thing the other day, that a circle is actually one dimensional. You know why?
Right.
You know why? The area inside the circle is two-dimensional, but the circle itself is just that circumference, and that is one-dimensional. It's measured in inches. It's not measured in square inches, the circumference. So in a way, a circle is actually one-dimensional, but most people think of a circle as being two-dimensional. It has an area. And then if you have a sphere, the volume of a sphere is equal to 4/3 pi r cubed. So that's the formula. Notice that there's only one thing to measure, and that's the radius. So if you have the radius, you can figure the area of a circle and the volume of a sphere that has that radius. Do they give you the radius?
They give the diameter, which is 12, so the radius is 6.
Okay. So we'll just plug everything in. We got 4/3 pi times 6 cubed, which is 4/3 pi times 216. That's what 6 cubed is. And then finish multiplying that out using your calculator. And it's better to give the answer in pi. In other words, my answer here is 864/3 pi. Now, can I simplify that? In other words, is 864 divisible by 3? You know how to tell?
How?
Add the digits up, and if the digits are divisible by 3, then the whole thing is divisible by 3. What does 8, 6, and 4 add up to?
16?
18.
Oh, okay.
Okay, and 18 is divisible by 3. So that is divisible by 3. So let's go ahead and divide it. 2, 26, 8, 24, 24, 288. So the answer is 288 pi. That's your answer.
Okay.
But those little rules about whether something's divisible by 3 or not, or whether it's divisible by 4 or 9, any number is divisible by 9 if its digits add up to 9. That's the golden rule. In other words, 108 is divisible by 9 because the digits add up to 9. 81 is divisible by 9 because 8 and 1 add up to 9. 72 is divisible by 9, so forth and so on. But it applies to a really long number. 1008, that's divisible by 9. So those things are helpful because if that is not divisible by 3, then I have my final answer. And I don't need to do this calculation over here. When I first looked at it, I didn't think it was divisible by 3. To be honest with you, I was adding them up incorrectly in my head also. And then when I saw that they added up to 18, I realized it is divisible by 3. All right. We got time. What else?
Hey, before you erase it, okay.
Sorry.
No, it's cool. Since I got it all down.
Yell stop or something. I don't know what's coming next.
I didn't need to take a picture of it. I just had a question.
Okay. We had volume equals 4/3 pi r cubed.
Right. Okay. We ended up with
6.
We ended up with 4/3 pi 216.
Right. 6 cubed is 216.
Is there a way to get from 4/3 pi 216 to 864/3 pi without a calculator?
No. In other words, you can't cancel any of these 3's. Okay, you can multiply 6 times 6 and then multiply it by 6 again, and that's how you get 216. But now notice what happens. Well, 216, those add up to 9. That means that number is divisible by 3. So yeah, there is a way. I can divide that and that by 3, and I end up with 4 pi times 72. And that gives you 288 pi. So there is a little bit of a simpler way to do it. But you still have to cube the 6.
Okay.
It'd be a little different if it was 3 cubed. Now 3 cubed divided by a 3 is the same as 3 squared. So I could reduce the math considerably if this number was the same as that denominator. But having a 6 cubed is basically 6 times 6 times 6 divided by 3. It's easier to do it this way.
All right, I'm just looking at some things here real quick.
Okay.
Because
Algebra 2 trig or just Algebra 2?
just Algebra 2, I believe.
Okay. Let me know when we get time. If you do start into trig, they might give you a week of trig.
Yeah, probably something
They might
like
not
that.
give you the whole semester of trig, but usually they start introducing trig in geometry and then algebra 2 a little bit more.
Yeah.
Okay.
Yeah.
All right.
Because these are like little the problems that I've been giving you are from like little tests that we have like once a week or something.
Okay.
And so that one that we just did, like they went straight from 4/3 pi 216 to 288 pi inches squared, and we're not supposed to use calculators on this, so I'm just not sure how to get there without using one, you know.
Okay, let's talk about that one more time. You do have to manually cube 6. Okay? That's actually one that's worth memorizing. 5 cubed is 125, 4 cubed is 64, 6 cubed is 216. Okay. Now notice they didn't do it the way I did it the first time, which was to multiply 4 times 216. The way they did it was the way I did it the second time. Was to treat this whole thing like it's the top of a fraction, and as all I'm going to do is I'm going to divide the top by 3 and the bottom by 3. I can always do that. Well, that is divisible by 3, so that equals 72. So you have 4 pi times 72. Still don't need a calculator. 4 times 70 is 280. 4 times 2 is 8. Got to be 288 pi.
Okay. Then I think for the moment that's all I have.
Okay. Sounds good, Jameson. Let me make a suggestion to your dad. When he signs up a session, if he could put either your name or Ricky's name on it, it actually makes it easier for me. Because then I know who to send the text to. I don't always get a chance to read the comments. And he usually signs it up under his name and then says it's either for Ricky or for you, or sometimes it's for Ricky. But I think that's where the confusion might have come from. Today's session or yesterday's canceled session or whatever it was. But that would probably make it easier. I think we'll have less problems if he signs it up on whoever is having the session.
Okay.
Okay? All right. I will talk to you next time. Have a good night.
All right. Thank you. Have a good night.
Bye-bye.